Okay, so in this video, we'll be looking at a DFA design exercise. So we're asked in this question to design a DFA which accepts the language of strings where those strings contain the substring ABA. Okay, so this is a very classic question in theoretical computer science classes for DFA design, where there's something about like a substring that you care about. And so the general thing that you want to do in this type of question is you kind of want to hard code the substring. So the sort of first step is to hard code the substring within your DFA, right? So what do I mean by hard code a substring? Literally have a path in the DFA that represents the string. So have something like A, B, A in the DFA. The second part that you want to have, or like the second step once you sort of hard code, is you sort of um, you kind of fill in the other edges of your DFA based on this idea of searching for the substring, based on a search uh, for the substring, based on, let's say, a logic that searches for. It's a better way of saying it. Okay, so what do I mean by that? Well, for instance, I'm going to do the entire DFA in a second, but what I mean by uh, fill in the edges such that you're implementing a kind of logic that searches for the substring is, well, for instance, here, um, if I'm sort of looking for the substring ABA, and this is sort of the beginning of my DFA that does this, that sort of hard codes and searches for the ABA. If I'm here and I see an A, well, that's great. Then um, I'm starting to go on this path towards the ABA. If I see a B instead, then what do you kind of want to do in this case? Do you like go to another state and then just reject? Do you go to this B here? You know, like there's different things that you could do. The idea is if this is sort of the component in your DFA that hard codes for the ABA, then at this point here, if you're seeing a B, well, you can just say it's kind of like you're in a reset state or in a sort of looking for the first A state. So that means that if you're here and instead of seeing an A, you see a B, well, you should probably just stay there and wait to see if in a few symbols from now, you're going to see an A. Because if so, then maybe that's the A, that's the first A in the ABA substring. So that means that if I want to implement this kind of logic of search, then I can say that I'm going to have a self loop for B at this state. And sort of this state is kind of looking for the first A in AB. Now, if there was like more stuff, if there was more stuff in this condition here, like for instance, ABA is a substring of W and the length of W is at least 5, right? Then the DFA would be a bit more complicated. But it turns out that if I just care about the fact that the string has the substring ABA, then what I can do is I can just say, make this state here the start state. So I'm going to make this state here the start state. So this is my start state, and all I care about is from my start state for me to at some point see the ABA, so to go through this path And once I do that, then I'm happy because I've seen at least one ABA in my string. So I don't care what's after, I'm going to accept, right? And so that's why this is going to be an accept state. And in particular, it's going to have a self loop for A and B, right? Because it's kind of like here, I'm searching um, for the ABA, right? And in particular, uh, for its first A. And here is essentially I found uh, the first uh, ABA substring, right? And so once I've done that, then whatever happens after, I'm happy whatever happens after because I've already found the first ABA, right? Because if I have something like uh, ABA here and then some other stuff's here, then I don't have to do any additional search because the condition is fairly simple here. I don't have to do I don't have to do additional search. I can just say, okay, well I've seen this first ABA. Now whatever happens here, I'm just going to stay in my accept state and accept regardless of what is after the ABA. It could end or there could be 10 more symbols. Okay. So now we've done the sort of first part, right, where it's like we hard code um, the substring ABA and the kind of logic for searching for it. Um, Now what we need to do is we need to sort of fill in the remainder of the edges because this has to be a DFA. So if I'm assuming the alphabet is AB, then each stage should have one edge for A and one edge for B, right? So the only place that I actually have this right now is here. So I need to fill in my edges. And remember, I need to fill in my edges um, such that I'm implementing this logic of searching for the substring, in this case, the substring ABA. So at my start state, right, at my start state, like I said, here, I can essentially say that if I'm seeing a B, well, I can just say, I'm just going to wait here, right? I'm going to wait here and see if the first A for that ABA comes. I'm going to wait here and sort of continue hoping that the first A appears. Then if the first A appears, then I get here. So that means that this stage can sort of be thought of as encoding some kind of information, where in this case, the information is uh, just seen an A. So if I've just seen an A, right, and I see another A, well, that means that I've just seen an A, right? So if I see an A and I see another A, I mean, that doesn't bring me forward in my search for ABA, but maybe this A that I see, so maybe I have a string like A. So maybe this second A that I see, that's actually the first A for the ABA. And so instead of sort of resetting the search, instead of resetting the search and going back here, I'm just going to wait here if I'm seeing an A because it doesn't hurt, right, to just stay here because I already know that I'm just seeing an A as my symbol. Okay, so you can imagine like this is useful if you have something like so if you have a string like B, A, and then maybe this A is the first A for the ABA. Then, I'm going to stay in here. I'm looking for the first A. Once I get here, I see that first A, but then it turns out that that was a bit of a false positive. It wasn't the A for the ABA. But I'm seeing, and in fact, it's because there's more A's to come, right? There's more A's to come, and so I'm just going to stay here and wait until it's actually the first A for the ABA, which will be signaled when I transition with this B to this other state. Okay. So suppose that I do transition from here to this other state, then this means that I've just seen. A and then B, right? So for instance, I've just seen A and then B here, so that's why I'm transitioning here. But now what if instead of an A, I see another B, right? Well, if I see another B, then I can't really say, oh, I'm just going to stay here, right? If I see a B, can't really say I'm just going to stay here because it's like um, it's not the B I wanted for my ABA because the pattern kind of just breaks, right? If I keep the B here, then I'm going to allow this false positive of, what if there's an A right after? Then I transition to the accept state, but I don't actually have an ABA. And I also can't transition back just one, right? And maybe another reason why intuitively I can't just transition back here is because this state here is for saying that I've just seen an A, right? But if I'm transitioning from here to here, reading a B, then that means that what's just happened is that I've just seen a B. So it would be incorrect in terms of what the information is encoded in the state to go from here to here, right? So it looks like the only option I really have is if I see a B here after an A and a B, I actually just have to reset my search. And that kind of makes sense because the only way for me to recover at this point and to actually accept a string is if I sort of start the whole process all over again and I see an A, B, and an A, right? So that's exactly what I'm going to do. I'm going to, from the state, reset my search and go back here. Okay. And so then if I have, maybe more B's, then some A's, uh, then let's see, some more B's. So, I think that I almost got it, but then I get another B, so I go back. But then maybe at some point finally, so maybe I have more B's. At some point finally, there's my A. So I have an A, and then I transition back here, then I have a B. So I transition here, and then I have an A. So I transition to the accept state. Then it doesn't matter what's after this. I have my ABA in my string. It really didn't matter what was here and what's after, as long as I had this one ABA, which I was able to detect because of this hard coding, right? Because this hard coding was here, I was able to immediately detect the first ABA and just accept, regardless of what came out. Okay, and so this is the DFA. This is a DFA. There's many others that you could have created. This is the minimal DFA that accepts this language here.